Students, welcome back to the online classes on Fluid Power System. This is Chetan Jadhav from Mechanical Department, Jain College of Engineering, Belgavi. Students, in today's class, we are going to study different applications of fluid power system. Also, working principle of Pascal's law and its applications. Students, there are so many applications of a fluid power system in almost all the fields. It may be hydraulics or pneumatics. If the work is heavier, we'll use hydraulics. Otherwise, for lighter applications, we'll use pneumatic equipments. Students, let me first list different applications of a fluid power system. First one is hydraulic lifter or scissor lifter. Second, hydraulic brakes. Third one is aircraft landing gear system. Fourth one is aircraft direction of motion control system. Fifth one is pneumatic controlled doors in automobiles. Sixth is industrial forklifts. Seventh is robotic arm and gripper operation. Eighth one is hydraulic powered excavators. Ninth is hydraulic powered cranes. And finally, dump truck. First application is hydraulic lifter. Sometimes it is also called as scissor lifter. These hydraulic lifters are used for height work like construction of multi-floor buildings, shopping malls, where we want to do welding operation or painting, etc. at a height of 20 feet to 60 feet from the ground level. At the top of hydraulic lifter, a platform is provided for the worker where he can stand and he can do his work. Since the mechanism used for lifting the platform is in the shape of scissor, it is popularly known as scissor lifter. As we can see from the animation, hydraulic cylinders are fixed to the lifting mechanism. As the cylinder starts extending, simultaneously the platform will move up, and as the cylinder starts retracting, the platform will come down. At the bottom side, there will be a hydraulic power pack, which is nothing but an assembly of hydraulic tank, pump, motor, direction control valve and pressure control valve. Hence, by using the hydraulic lifter, we can do height work ranging from 20 feet to 60 feet. Let me explain the direction of fluid flow inside the cylinder of a hydraulic lifter. As you can see from the animation, during the forward stroke of the cylinder, hydraulic oil will flow from the pump towards the chamber A of cylinder, and it will push the piston in upward direction so that we can lift the platform. Then, as we change the direction of fluid flow using direction control valve, due to self weight of the lifter, piston will come down and simultaneously hydraulic oil will flow back to its tank, hence the lifter will move down. Students, next application is hydraulic brake. When a vehicle is moving at high speed and suddenly we want to stop the vehicle due to some obstacles, then we can use hydraulic brakes for instantaneous stopping of the wheels. There are two types of brakes, disc brake and drum brake. Both will work on the principle of Pascal's law. Next application is aircraft landing gear system. Aircraft landing gear system is an assembly of wheels and shock absorbers. The purpose of using this landing gear system is to assure smooth landing of the aircraft without any vibration or damage to the aircraft. The wheels, which are equipped with shock absorbers, will damp the vibrations during the landing of aircraft. These wheels are also connected to one more actuator so that the wheels can fold inside and outside during takeoff and landing of aircraft. The next application is aircraft direction of motion control system. Students, let me explain how an aircraft direction of motion is controlled using hydraulic actuator. Basically, there are three types of direction control system in an aircraft. First one, pitch control, rolling control, and yaw motion control. Students, in the animated video you can see that this is the pitching of an aircraft, this is the rolling action, and this is the yaw motion of an aircraft. Students, let me explain these three types of control system one by one. First one is pitch control. From the figure we can see that at the trailing edge of an aircraft there is a blade like structure which is highlighted by yellow color, is hinged to the horizontal wing of an aircraft. These blade like structures are known as flaps. These flaps can move up and down, and the movement of these flaps is controlled by an actuator which is known as elevator. As the flaps moves up, the front or the nose of an aircraft also moves up. As the flaps moves down, the nose of an aircraft also moves down. Hence, by varying the direction of these flaps, we can vary the lift of an aircraft. Hence, we can control pitching action of an aircraft. Second one is a rolling control. From the figure we can see that the side wings of an aircraft are connected by a blade-like structure which is highlighted by a green color. These blade-like structures are known as flaps. These flaps will move alternatively up and down. It means one flap will be up and another flap will be down. The wing on which the flaps are in upward direction, that wing will come down due to variation in the lift. The movement of these flaps are controlled by an actuator which is known as aileron actuator. Hence, with the help of aileron actuator, we will be able to control the rolling action of an aircraft. Finally, the third motion control of an aircraft is yaw motion control. Yaw motion means left and right motion of an aircraft. From the image we can see that the vertical wing which is present at the trailing edge of an aircraft is hinged or connected by a flap which is highlighted by orange color. By moving this flap either to the left or right, we can control the yaw motion of an aircraft. The movement of this flap is controlled by an actuator which is known as a rudder actuator. As this flap moves left, the nose of an aircraft will also move left. As the flap moves right, the nose of an aircraft will also move towards the right direction. In this way, you can control the yaw motion of an aircraft with the help of a rudder actuator. Students, the fifth application of fluid power system is pneumatic controlled doors in automobiles. As we have seen in modern buses, the doors will open and close automatically. Usually these doors will be connected by pneumatic cylinders which are present at the back side of the doors. As the cylinder extends and retracts, the door will open and close. Hence, with the help of pneumatic cylinder, we can control opening and closing of doors. The sixth application of fluid power system is industrial forklifts. As we have seen in the industry, for material handling purpose, if you want to transfer the material from one point to another point, we can use these forklifts. The forks of these vehicles are controlled by hydraulic actuators. Students, these are the side view and the front view of the forklift. From the animation we can see that the forks will be connected to the actuators. As the actuator extends and retracts, the fork will move up and down. And also we can see the movement of hydraulic coil inside the cylinder. Hence, with the help of hydraulic actuator, we will be able to control the movement of forks. Hence, we can use for material handling purpose. The seventh application of fluid power system is robotic arm and gripper operation. As we have seen in the industry, robots are used to transfer the object or material from the conveyor towards the workstation. And these robots will be having end effectors or grippers which are used to hold and release the object wherever required. The movement of these end effectors is controlled by pneumatic cylinders. As the cylinder retracts, the end effector will be able to hold the object, and as the cylinder extends, the end effector will be able to release the object. Hence, with the help of pneumatic power system, we can control the robotic arm and gripper operation. Students, next application of fluid power system is hydraulic powered excavator. The function of this excavator is to remove the soil from the earth crust. It is having different parts like excavator bucket, excavator arm, sometimes it is also called as excavator stick, and excavator boom. The movement of these components is controlled by hydraulic actuators. For example, the swing of bucket is controlled by a bucket actuator. The front and back motion of the arm is controlled by arm actuator. And the height of the excavator boom is controlled by excavator boom actuator. Hence, with the help of hydraulic cylinders or actuators, we can control different components of excavator. Students, from the animated image of an excavator, we can see how the hydraulic coil will travel from one point to different point of the excavator. At the rear portion of the excavator, engine will be present, which consists of hydraulic tank, pump, motor, direction control valve and pressure control valve. High pressure fluid which is coming from the pump is used to extend and retract different actuators. Hence, with the help of excavator, we can convert hydraulic energy into mechanical work. Next application is hydraulic powered cranes. Hydraulic powered cranes are used to lift and transfer the heavier objects from one location to another locations in construction of buildings. The hydraulic cranes consists of telescopic cylinders, and these telescopic cylinders are special type of actuators which are available for the applications requiring long extension distances. These telescopic cylinders consists of two or more cylinders which are enclosed in a single casing, and they will extend and retract one after the another. Last application of a fluid power system is dump trucks. I think we have seen the working of dump trucks in our daily life. Dump trucks are used to load and unload the sand particles or soil during house construction purpose. These dump trucks also consist of telescopic cylinders which will extend one by one. This is all about applications of fluid power system, starting from hydraulic lifter to dump trucks. Moving ahead, let me explain the working principle of Pascal's law. Consider a container filled with a fluid as shown in the below figure. When we apply pressure P on the piston will transfer the pressure to the fluid, such that pressure at any point inside the fluid will be same in all directions and it is perpendicular to the surface on which it acts. Hence, we can state the Pascal's law as pressure applied to a confined fluid is transmitted undiminished in all directions throughout the fluid and acts perpendicular to the surfaces in contact with the fluid. Students, let me discuss what is application of Pascal's law. Consider a container which is having a liquid and it is having smaller piston at the left side and bigger piston at the right side. From the figure we can say that F1 is force acting on the smaller piston, A1 is area of smaller piston, S1 is smaller piston stroke. F2 is force acting on bigger piston, A2 is area of bigger piston and S2 is bigger piston stroke. As we apply force F1 on smaller piston, a pressure P1 is generated, that is equal to F1 divided by A1. And this pressure will be transmitted through the fluid in such a way that pressure at bigger piston will be P2, that is F2 divided by A2. Then, as per the Pascal's law, pressure at smaller piston is equal to pressure at bigger piston, that is P1 is equal to P2. Hence we can write F1 divided by A1 is equal to F2 divided by A2. From the above equation we can say that force is directly proportional to cross-section area of the piston. It means if we apply smaller force at smaller piston, we'll get larger force at larger piston, which is nothing but multiplication of force. Hence, we can use Pascal's law in hydraulic press and hydraulic jogs to generate maximum output force with the help of minimum input force. Let me solve one problem on Pascal's law so that we can prove that we can convert a minimum input force into maximum output force. Two pistons of a hydraulic lift have diameters of 60 cm and 5 cm. Then what is the force exerted by the larger piston when 50 Newton is placed on the smaller piston? As per the given data, diameter of smaller piston is D1, that is 5 cm. Diameter of bigger piston is D2, that is 60 cm. F1 is equal to 50 Newton, which is acting at the smaller piston. We need to find the force exerted at the bigger piston. Then as per the Pascal's law, pressure at smaller piston is equal to pressure at bigger piston, that is P1 is equal to P2. Then we can write F1 by A1 is equal to F2 by A2. After substituting the values of D1 and D2, we will get area of smaller piston as A1 and area of larger piston as A2. Then with the help of equation, we will get F2 as 7200 Newton, which is more than input force. Hence, with the help of Pascal's law, we can convert minimum input force, that is 50 Newton, into maximum output force, that is 7200 Newton. Students, this is all about applications of fluid power system and applications of Pascal's law.